Welcome to ScreenFlow on rows and columns and using data frames. So in addition to working with the console down here, I'll actually start also to working with source code, our source code, which we can save it as any name we want. So I guess to get started, let's create some variables. Create a variable called names, specifically a vector called names, and let's define it with Jeff, Jan, and Joe. The way we run this is over here we execute the command, and now we have a variable called names. It's a vector. It has 3 elements, 3 strings, Jeff, Jen, and Joe. We can even create a GPA, another vector. And that would be 3.9, 3.8, 3.5. See, if I hit return up there, nothing happens. I have to actually hit the run command, and it runs the current selection or where the command cursor is. So it kind of runs that one line. If I select both of these lines and then hit run, both of those lines run. So now I have source code, and again, this is my console. So I can go down here and still do all the things I was doing previously. I could take a look at the vector called names, and out comes Jeff, Jen, and Joe. So that's all kind of the same kind of thing. So we're going to have 2 vectors, names and GPA, and I can use that to create a data frame. So let's do that, but I'll do the data frame up here so we can kind of reuse it later if we need to. So the data frame equals data.frame. This is the command to create a data frame. And then we're going to pass it in 2 vectors, names and GPA. I run that, and now I have a data frame. So I can look at the data frame a number of different ways. So I can just type df, and I have, again, 2 columns and 3 rows with 3 instances. I can also look at the structure of df. And it tells me, again, there's 3 observations. These observations are a row, 2 variables. Each variable is a column. And here's a description of each of the variables or attributes. So it has a GPA, and that's a number, and it's got names, which actually is a factor of 3 different levels. So rather than keeping it as strings, it said there's only 3 types of strings, so R is going to be smart and just store it as a factor. Now let's say I wanted to grow names, add a name to names, if you will. Remember we did this last week, in terms of adding a vector. So we can add a new vector, a new attribute, if you will, or a new index into the name. We can run that. So now, names has 4 elements, not 3. So my question is, before we start going some more, did df change? So remember df was names and GPA, and we created that using this data frame based on names and GPA. So did the actual data frame known as df change because we changed the variable name of names? Well, if we take a look at df, we can see it actually has not changed. Just like when we created a variable last week, created a vector from a variable, when we create a data frame from a series of variables that are vectors, it's copied over. So df is in different locations than names or GPA. So no matter what we change in the variables individually or the vectors of GPA and names, the data frame variable is a different variable, so one does not affect the other. So let's try to actually then grow the data frame. So let's say we want to do data frame equals, so we're going to add a new row. So that's called row bind. So we want to kind of go with our current data frame and add 1 row. And the row would be Pat with a GPA of 3.3. What caused that error? Well, if you can take a look, you can see it says invalid factor level. So if we take a look at df, you can see that over here it added an NA. Because remember, names was a factor, so it only had 3 choices. So we tried to carry to the 4th choice of Pat, and R said no, there's only 3 possible choices. So there's a way to do that, but we have to kind of recreate df. But if you notice, I overwrote df. But no need to worry. We can kind of recreate our code. That's the advantage of kind of storing our source code. So we get back our data frame as we want, but now we have to create the data frame actually not using this command, because if you take a look at the structure of this command, structure of the data frame, sorry, again we have factors. So instead, we're going to create a data frame, and then we'll do key here is string as factors equals false. So we're telling R, don't create any factors, keep them as strings. If we look at structure of df, because you can see now names is not a factor, it's a set of strings. So now if we execute the code that we tried before, scroll back where we can find it. Here's the code. We want to take and add additional row and add pat in the GPA of 3.3. So now it worked. It worked because the column names is not a factor, but it's just a string. And there we have what we're expecting. Let's add a new column. How about create a new vector called age? We'll add it up here. So all right, get rid of this. We'll add it up here. We'll say age 30, 25, 38, 22. We'll run that command. Now we have a vector called age, as you can see. So now we want to add a new column. So create a new data frame called dfNew, and we'll do a column bind called cbind. And we'll do df and age. We take a look at dfNew. You see it added a new column. Right? So it kind of, you can add either rows or columns to data frames, similar to how you can kind of add new elements to vectors by growing them. Now let's spend a little time accessing the data frame. So we can say dfNew sub 1, 1. What does that generate? That's Jeff. How about dfNew 1? What does that return? As you can see, it returns the first row. So that's a way to access information. We can also return the second column, for example. So the row and column indices here give us the exact element we're looking for. And if it's blank, it gives us all of the rows or all the columns. So we can kind of think of the data frame as this rectangular grid, and our indices are kind of accessing the right element in that 2D matrix. So to experiment a little bit more, how about, let's see, we have age. Remember we have age? We have dfAge. So let's say dfAge, df$age plus 2. Why did that give an error? What do we think that does? What's the issue there? Well, let's take a look at structure df, because it's dfNew. So we probably should do dfNew, right? Because we added age as a third column in dfNew, but not df. So this worked, and we can take a look at dfNew. We can see the age. Everybody is 2 years older. So just like we were able to do vector math on simple vectors, we can do vector math within a data frame. And maybe one more thing about data frames. Let's do dfNew minus 1. What do you think that does? Yes, it removes the first row. And similarly, minus 1 here removes the first column. And we could do, removes the first 2 columns, so there's only 1 column left. So the minus signs remove, and we can kind of take a look at it that way. We can also just take a look at So you can kind of access a range of numbers, not just one column, for example, one row. So we're going to take a look at columns 1 and 2, but not 3. That's why we can see ages. Let's create a new column a different way. Let's say we want to calculate age per GPA. And we're going to say that is a function, or is defined by the GPA divided by the age. Why did we get an error there? What do you think the issue is? Why doesn't this code work? Well, if we take a look at, we can see GPA are not numbers, they're character strings. So we have to convert the GPA into a number. We have to tell R that we want to think of 3.9 as a number, not as a string. So we get df new $GPA. We can say it's as numeric. So we're saying treat that column as numeric and store the results back in the same name. So now if we go back to look at the structure again, now we see GPA, or I think of those as numbers, not as strings. So now if we go back and do our operation, it actually worked. And if we say df new, we can see another new column. And this is this ratio we were calculating, which might be useful, might not. But that's how additional ways we can kind of create intermediate results and store them and do additional calculations on our data frame. Maybe one last thing before we stop. Work a little bit with indexes. So we can say, which is the biggest? So which.max doesn't return the maximum of df age, it returns the index of the maximum age. Then if we wanted to see, we can see, for example, of df new $age sub 3, that's the largest one. I sure hope so. Let's take a look. Age 40, yes it is. So again, which.max is a function that returns the index of the largest, for example. Which.min would be obviously the smallest. But we can use that index like we've been using it before. And I think we'll stop there today.